I'm playing with the KidWind GenX Alternator kit again. Again, this is set up with 4 magnets on a steel plate back here. I've got 3 coils set up, 120 degrees apart. I've got the shaft here so I can slide it. And this is set up for 3-phase right now, so there are the 3 phases. See what happens when I move the magnets closer. Get a little pulse on there. So I can spin this. You can see it generating some power there. Got the 3 phases. You can see each phase is 120 degrees offset from the next. But what I'm really playing with here is the motor now, and it's kind of fun to look at some different things. Got the DC power supply here. So this should want to run now as a motor. It runs really smoothly. Hit auto range here and see if it'll. Fine, I'm doing something wrong. So I'll do a 10-volt scale. I'm adjusting the scale on the meter. There. Take a little more. So that shows the waveforms. Now it's kind of fun to see what happens when I put a load on it. I'm just going to grab it here and break it. You can also see the power it's using. We've got volts, amps, and watts. Volts will be constant. Let's see, when I put the brake on, it's using a lot more power. It's using 4 watts. If I let it idle, it's only using about half a watt. The thing that's interesting and a little surprising to me, and Dylan over there suggested it must be the shape of the flux coming off the coils, but I've got the magnet rotor in pretty close to the coils right now. If I push the shaft back and move the magnet rotor back, it speeds up dramatically. And the waveform gets weird. And it also uses a lot more power. It's using 4 watts idling now. If I bring this back, it'll only use about half a watt. It's coasting now, but it'll come back. It's back to about a half watt. Kind of interesting. I didn't expect that anyhow. I should add, I am wearing safety glasses. This thing could get dangerous. I'm driving this with this little brushless motor driver. So this is only at 8 volts right now. I can bring it up quite a bit. Take it up to 15. Now if I push the shaft back, it's using about 6, 7 watts, 9 watts. Should we try to blow it up? And move out of the line of fire. Dylan's moving out of the line of fire. It's only 20 volts. It's using 2 watts. When I put a load on it now. What happens if I move the magnet rotor away? I just felt something hit my arm. Something broke. So that was the 3D printed cage that I put around the magnets. I was worried about magnets flying out of these, so I printed a 3D cage that'll hold the magnets. It exploded. This is what the cage looked like. It was 3D printed like this. Except this one was actually stronger than this one. But yeah, pretty amazing. And the magnets were also glued down underneath that. So don't try this at home. This now has no magnets. And it doesn't work at all anymore. And I don't know where the magnets went. Glad I was wearing safety glasses. I'm glad Dylan moved.